The motion of a rocket lifting off a launch pad is determined by Newton's laws of motion. In this lab, students will create balloon rockets powered by escaping air. They'll observe the rockets to answer the question, how do Newton's laws of motion explain the motion of a balloon rocket?
Right now we're going to observe Newton's third law of motion in action. And we're going to do this with what we're calling rocket balloons. On your desk you have materials to do this activity. You have in your plastic bag, you have string, different size balloons, straws, tape, a stopwatch, and a meter stick. You will have to record your data in your notebook. Okay. Even before we get started, does anybody know what Newton's third law of motion is? Robert?
For every action, there's an equal and opposite reaction.
Okay, so that's what we're going to be seeing. You're going to observe Newton's third law of motion. Okay, so you have your materials. You know what it is you have to do. You may begin.
I inserted the straw into the string.
Okay.
And tied it so we don't drop it into the rubber.
Anybody, you set the data table up yet? So we have to make 3 trials, right? With 3 different balloons. Is that right? Well,
Does it say to do a table? 3 different balloons.
well, you're going to have to figure
You're
out.
gonna have to record
Yeah.
your information.
So just balloon 1, 2, and 3.
We need to have our
1, 2, and 3.
so
Yeah, we should put our goggles on.
Safety first.
Time.
average speed.
So we need distance and time, and that should get, we can get average speed.
Okay.
It'll be distance divided by time. So the distance will be in meters, and the time will be in seconds.
Where should we tie it?
We have to measure it first. Distance from end to end.
Are we just gonna hold it?
I think holding it is just easy.
Right, that's what I'm saying.
Yeah.
So I'm measuring this.
Yeah.
Yep.
Okay, so that's
100 centimeters. 200 centimeters. 400.
okay.
500. We want it to
through
go
here.
vertical so that it would.
Oh yeah, tell me when you're going to so I can.
Is that what you wanted to do? Okay,
Why?
because you'll be,
Oh, so that it would go.
You know, can we come on the other side of you?
Yeah, I think we should rethink how we're taping the balloon
Okay.
because I think we're obstructing the airway.
Yeah. That's true. That's true.
So you want to take that off?
Yeah, I
Yeah.
think we should tape it somewhere in the middle so it's on top.
Because this is a.
Got it?
Yeah, I got it.
Is it gonna blow?
Probably not.
Okay.
We can stretch.
I got a different piece of tape.
Okay. So we should tape it like this. Okay. Just put tape like here.
Okay,
Put
let it
more.
go. More?
It's going to flip over anyway, so you should just let it hang low.
Okay.
So it's okay, or you want more tape?
You know what I'm saying?
Put one more tape
Below the
on.
bottom. It's going to turn over anyway.
Okay.
Okay.
So we're going to put this on the bottom.
There you go.
Okay.
Okay.
Whenever you're ready.
Yep, you say 3 and then I'll go.
3.
One.
Okay.
Okay, go ahead.
3, 2, 1, go.
Stop.
At 3, okay? 1, 2.
This will be 4.
Fill it. More air. Yeah, more air.
Do you have goggles to put on?
It's got to start at.
Come on.
Okay.
So,
So it started here.
3, 2,
368.
okay.
Stop.
368?
So 3 meters and 68 centimeters.
Not that way.
You think your kids enjoy this?
Yeah, this is fun. I'm enjoying this. Are you ready?
Are you ready?
Okay. 3, 2, 1, go. Did it pop off or something?
Can reuse this.
No,
Some force there behind that.
A reaction is an equal and opposite reaction.
Dorothy, I think you should put more air in there.
Do you want me to get more tape or were those usable?
Let's get new tape. We're not on a
Maybe we
budget.
need bigger pieces of tape. Let's try that. Okay.
Try it on the bottom.
Try this way.
Yeah.
What was the time?
170.
Okay.
Got it?
Whenever you're ready.
Put it on the bottom. Because it's going to fly back. Okay. 3, 2, 1, go.
Stop. What was that one?
2.82.
Okay.
2 seconds.
6.
Dorothy, I think you should put more air in there. Okay, so what are some of the things that you had to make sure you did in order for your balloon to travel a far distance? Michelle?
We had to make sure that we had enough air in the balloon.
Okay. Anything else?
You had to make sure the balloon was taped onto the straw well. You also had to make sure that the nozzle from where the air comes out of the balloon is parallel with the floor. Otherwise, the balloon would spin around and slow down.
Okay. Corey, you mentioned one other thing that you said had to happen in order for the balloon to travel far. What was
It
it?
seemed that the string needed to be tight rather than loose.
As I was looking and you were setting up your investigation, I saw that you did something to your string. Can you tell us what you did and why you did it?
We marked the meters on the string.
Okay, you marked the meters on the string. Why did you do that?
So by marking each meter on the string, it made calculating the distance easier because we would only need to calculate the distance from the last mark, which was the last meter, to the end of the line.
How did you see Newton's third law while you were doing your rockets, your balloon rockets? How did you see Newton's third law playing out? Michelle?
Well, what we saw was when the air escaped from the balloon, that was the action, forcing the balloon to travel down the string, which was the reaction. So that's a visible case of Newton's third law.
Okay, good. Thank you. How do you think your students would like this activity?
They would like
I think they'd love it.
They will have fun.
You could, I think it would, like I would set this up as a race because I think my students would like to have the balloons race each other. So you could do the exact same thing except make all the balloons shoot one way and then have the kids still time, but then they're racing. And you could even have a, you know, brackets or whatever you wanted to have the champion at the end.
You can also, like, adding on to that, you can also have all the balloons end at the same point, so
Right.
that way you can see who comes first, second, third.
Right? That'd be good.
Good. Thank you.
In the balloon races lab, students should compare and contrast the distances traveled, calculate a balloon's average speed by noting the time and the distance the balloon travels, infer which aspects, balloon size, shape, and air capacity, the thickness of the rubber from which the balloon is made, and the size of the opening made the rockets travel far or fast.